Junior students, parents and viewers, welcome to Olympiad Primer. In this video, today I will teach an interesting proof technique that are generally used in many hard mathematical argument and mathematical proof. Though the problem is based on very junior class, that is addition problem, but the technique that are followed in this solution is very much in higher mathematical section of higher mathematical logic. So especially for the junior students who wants to become more advanced in junior age to solve the mathematical argument and logical problem, they can easily understand and learn the proof technique. Just the problem is a 17-digit number is chosen, another number having its digits are reversed. Two numbers are added together so that their sum contains at least one even digit. This is the today's problem. We should solve this problem. How can we solve this problem? How can we show that at least one of the sum digits would be even? Here we should follow a strategy. The strategy is nothing but at first suppose the digits of the first number is like A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P and Q, and the another number having the reverse digits will be from right to left A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P and Q. So these are the two numbers, and if we add these two numbers, then we will get a sum, and we have to prove that at least one digits of the sum will be even. And suppose we can number the column from the right to left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. So these are the number of columns, and if we add these two numbers, the numbers A to Q and Q to A, then we will get a sum, and suppose the sum number, the digits of the sum number are all stars. Okay, like all the 17 digits of the sum are expressed by stars, 17 stars. According to the question, we have to prove that at least one star, because one digit of the sum must be even. So we have to prove that at least one star must be even, and our strategy would be that at first we should assume that all star would be odd if possible, and then by this assumption we should observe the mathematical phenomena and the addition, and if we come into the situation where any contradiction, where we face any contradiction, then it will prove that there at least one digit must be even. So this will be our strategy. So let us go ahead. First let us assume that all stars are odd if possible. Now we consider the addition, but at first we go for the ninth column. Consider the addition of ninth column. what is the digits there in ninth column? There the digits are I and I, the same digits. And if we add these two same digits, that is I plus I, what will we get? We will get an even number. Here pink star is expressed the sum of the two I, but we have already assumed that all stars are odd. So here I plus I though is even, but the pink star is also odd as per assumption. But this star, this pink star, that is the addition of 2i, the sum of 2i will be even only possible if there will be a carry from 8th column, isn't it? So it implies that there is a carry 1 from 8th column, and in 8th column, what are the digits? In 8th column, the digits are J and H, and also we can see that J and H are in the 10th column, H and J in reverse order. In 8th column, there are J and H, and in 10th column, there are H and J. So the same digits in 8th column and 10th column. So since the 8th column will produce a carry, so 10th column will also produce a carry 1, isn't it? And this carry will go into the 11th column. So there is a carry 1 from 10th to 11th, and 11th and 7th column are also the identical. Here see, in 11th they are G and K, and in 7th column they are K and G in reverse order, but the digits are the same, isn't it? So just see, in 11th column there are G and K, and in 7th column there are K and G. So if the 11th column will require a carry, so the 7th column must also require a carry, isn't it? So we can just by seeing this feature, we can easily understand that 11th and 7th column are the identical. Because of the 11th and 7th column are identical, so since there is a carry from 10th column to 11th column, so there must be a carry from 6th column to 7th column, because 11th column and 7th column are the same. The digits of 11th column and that of the 7th column are the same. So here, which implies that there is a carry from 6th to 7th. So in this way we proceed. Again 12th and 6th, the elements of the digits of 6th column, there are I and F, and in the 12th column there are also F and I. The digits are the same but in reverse order. So when we add I and F and I, we will get the same parity, isn't it? So since the 6th digit, that is I and F, will produce a carry to go into the 7th, so the 12th digit also will produce a carry to go into the 13th column, that is. So we can easily say that the 12th column will produce a carry, and which will come into the 13th column. So there is a carry from 12th column to 13th column, isn't it? So clearly So if we proceed in this way, then we can observe a phenomena here that easily understand it, and we can observe this, that uh, any odd numbered column must get into a carry, isn't it? So we can say, we can come to the conclusion that if we proceed in this way, just here also, if we look that 12th column to 13th column, that also in another side, the uh, there is a carry from 4th column to 5th column. So hence, if we proceed in this way, then we can observe it, that there must be a carry into any odd numbered column, so everywhere. And if uh, we come into the 16th column to 17th column, when a carry uh, from 16th column to 17th column, because the even numbered column to odd numbered column, there must be a carry. So when the carry uh, from 16th column to 17th column, what will happen here? If you look at very minutely, that the digits in 17th column, there are A and Q, and which are the same as in the first column, that is Q and A. So if 17th column requires a carry from 16th, so the first column also requires a carry. But what we see, that the first column has nothing to supply this carry, because it is the first column, isn't it? The first column also requires a carry, but the first column uh, did not get any carry. There is no chance of any carry into the first column. So it is a contradiction. According to our assumption, we can face this contradiction, because according to the 17th column, we can see that the first column also requires a carry, but the first column has nothing to get into this carry. So it is a contradiction, and this contradiction proves that there are at least one digits, there are at least one star of this sum 17 digits will be, must be even. So the proof is complete. So this is the solution of today's logical mathematics. The problem is based on very junior class, but the proof, the technique, the proof, the technique of the proof is very much interesting. And I think the juniors student of class even 3, 4 to 8, 9 can enjoy, learn this proof technique, and they can easily solve any mathematical argument and any mathematical decision by this technique of assumption and contradiction. For more such mathematical argument and logical problem and technique, subscribe and like my channel. And my dear students and viewers, feel free to give any comment in favor or against my solution and my opinion. Thank you once again for watching this video, my students and viewers.